This is day 3 for Unit 6. Still working with trig today. We're moving on from right triangle trig to non-right triangle trig. That's another way of saying a non-right triangle is saying an oblique triangle. That's another way we describe a non-right triangle. It's called an oblique triangle trig. So today we're going to be looking at the law of cosines. So for a right triangle trig, anytime we have a right triangle, we're just using our basic trig ratio, sine, cosine, tangent. We're using SOHCAHTOA. We have oblique triangles, where we can split them basically into two categories using our triangle congruence theorems. And those two categories, we're either going to be using the law of cosines, which we're going to look at today, or the law of sines, which we're going to look at tomorrow. So the categories for oblique triangles basically are broken up by triangle congruence theorems, which you should have studied or seen when you did Math 2 and Math 3. So there are 5 triangle congruence theorems. There's side, 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 angle, side, angle, side, angle, 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 side, and then there's hypotenuse, leg as well. Since hypotenuse, leg obviously is 4 right triangles, this is something we'll use right triangle trig for, and not law of sines or law of cosines. For side, 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 angle, side triangles, this is where we're going to use the law of cosines. And then for angle, side, angle, 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 side, we'll use law of sines. So they basically split up along the congruence theorems into two categories. We'll use law of cosines for side, 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 or side, angle, side information, and law of sines for angle, side, angle, or angle, angle, side information. So there's a few variations of the law of cosines formula. Basically, if we have an oblique triangle, label the vertices ABC, the corners. The opposite sides are labeled with lowercase letter. So opposite A is lowercase side length A, opposite B is lowercase side length B, and same thing, opposite C is lowercase side length C. So lowercase letters represent side lengths, and capital letters are going to be used to represent angles in these formulas. So that's just a note about notation. It's the same way we do law of sines, and most things we'll do with trig, you'll see that same convention used where capital letters are angles and lowercase letters represent side lengths. So the law of cosines formula starts out like the Pythagorean theorem. A squared equals b squared plus c squared. There's another part added at the end. Minus 2bc cosine A. So then there's 2 other variations of the formula. We can switch these numbers around. It'll still be the same formula. You can put b on the other side. B squared equals a squared plus c squared minus 2ac cosine b. Or third way, we can put c on this side. C squared equals a squared plus b squared minus 2ab cosine c. One thing, notice when we switch this around, when we change the formula around, which you'll have to do to solve some of these triangles, you always see that we have side length on the left-hand side and its opposite angle in the cosine argument, the cosine on the right-hand side. So we have A on the left-hand side, we have cosine A on the right-hand side. B on the left-hand side, we have cosine B on the right-hand side. Same thing here, C and angle C. So always make sure you have that agreement. As long as you do that, the formula will usually be correct. There's not a whole lot of ways mess up writing down the formula. Just remember that first part is like Pythagorean theorem, and it's only that second new part you need to remember. So we'll go through two examples of solving an oblique triangle and one application word problem. So first one we're going to do is we're going to solve a side angle side triangle. So it means to solve a triangle is to find all the missing pieces. So that means all the missing side lengths and all the missing angles. So just like with the other trig stuff we've done, it's always helpful to draw a picture. It doesn't matter if your picture's to scale or if it's neat. Um, it just has to be a picture so you can visualize the problem. So you draw a general triangle, label it ABC. Right? Remember that the uppercase letters represent the angles, and then their opposite side lengths have lowercase letters. Right, so once we have this triangle, we can go ahead and fill in our information that we're given in the problem. We know this angle here at A is 60 degrees. We know that side length B is 20 and side length C is 30. Right, this is how we get a side angle side group. You can see we have two sides, C and B, and the angle in between them, the included angle, angle A. Right, so once we have the picture, we can set up our formula. We only know one angle here, so we're going to have to make sure that angle appears in our formula. In order to do that, we need to make sure that if angle A is in the cosine, then side A is going to have to be on the left-hand side. So I have A squared equals B squared plus C squared minus 2BC cosine A. We need to make sure that angle A is in the formula because that's the only angle that we know. Everything else from here on out is just plug and chug. We're going to plug in and we're going to evaluate. So we don't know A yet. That's what we're going to be finding out here is the side length A. We know B is 20. C is 30. And then we know angle A is 60 degrees. So keep working down the page. 20 squared, 400, 30 squared, 900. 2 times 20 is 40, and then times 30 would be 1200 cosine 60. One important thing to note here, a very common mistake people make using this formula, is that this 1200 is coefficient for cosine. It's stuck to cosine. We can't subtract 400 plus 900 minus 1200 and then multiply by cosine. These are stuck together, so they have to be evaluated together. One thing we do know from yesterday with special right triangles is that cosine 60, right, if we draw a special right triangle real quick, a 30, 60, 90, label the sides 1, 2, square root 3. We know cosine for 60 degrees adjacent over hypotenuse is 1/2. Right, that makes this a little bit easier. Again, we don't need a calculator to evaluate ones like that. And again, if your calculator wasn't in degree mode or you made a small mistake putting that in, you could end up getting a much more difficult answer than if you just use the non-calculator version. So we have 400 and 900. It's going to be 1300 minus 1200 times cosine 60, which is 1/2, be minus 600. So I have A squared equals 700. I'll take the square root. So get A is about 26.5. So we can go ahead and fill that in on our triangle. Right now we still need to find the measures of angle B and angle C. So we're going to have to use the same formula again, same process with law of cosines, because now we're going to have to change the formula around to get either angle B or angle C involved, which means we're going to have to start with one of those side lengths on the left-hand side. So just for example, we can put b on the left-hand side. We'll have b squared equals a squared plus c squared minus 2 ac cosine b. Right now the angle b is in the formula, so I can actually solve for it. I know everything else at this point that will go into this equation. So b is 20, so start filling in the formula. So we have 20 squared equals a squared 26.5 plus c is 30 squared minus 2. A is 26.5 and c is 30 cosine b. All right, everything else from here on out we just need to simplify. So we have 20 squared is 400 equals 26.5 squared. That was a squared. We had from the previous problem was 700 plus 900 minus 2 times 26.5 times 30 is 1590 cosine b. So 700 and 900 makes 1600. We'll subtract that, move it to the other side. So we'll have negative 1200 left-hand side equals negative 1590 cosine b. Then the last thing to solve for cosine b, isolate the cosine, divide by negative 1590. So negative divided negative will make it positive. So I'll have cosine b is 1200 over 1590. Right, and going back to what we did yesterday, we know the cosine ratio, so we can find the measure of the angle using the inverse cosine. So again, on our calculator, that'd be second in cosine. Make sure it's in degree mode, and the angle you'll get round up is about 41 degrees. Right, so the angle B is 41 degrees. Right, last thing we need to find is angle C. So for finding angle C, we don't need to use the formula again unless you just really enjoy using the formula and going through all this arithmetic. You can just use the triangle angle sum. We know all three angles have to add up to 180. So if we take 180, we subtract the other two angles, 41 and 60 from 180, we can find the measure of C without having to plug into that formula and go through all that calculation. So if we subtract these, we end up getting C is 79 degrees. So that's our triangle is now solved. So we have all three angles, all three sides. The last thing I want to check for is just make sure that there's agreement. The smallest side should always be across from the smallest angle. So in this case, B is the smallest angle, 41. It's across from the smallest side, 20. So that checks out. Same thing with the largest side is 30. C across from the largest angle, 79, which is angle C. So that checks out. And obviously the two middle ones are in the middle. So always make sure you check that just to make sure your answer makes sense. If you made a small mistake, sometimes I can throw off your answer. And if you check at the end that the small sides line up, small angle, small side line up, largest angle, largest side line up, that can help you avoid some of those mistakes. So one more example of solving a triangle. This one's going to be a side triangle. Do a word problem, that'll be it. So starting off the same way, we just take general triangle, label it ABC. fill in our information. In this case, all we know is the three side lengths. So we have A is 6, B is 9, and C is 4. So we need to find the three angle measures. Right, so we can start off with the formula written out anyway, um, knowing that we're going to have to solve for all three angles. Right, so we can just start with A, so A squared, B squared plus C squared minus 2BC cosine A. You don't need to always write out the formula at the beginning to start off with. Once you get better with using the formula, you won't have to actually write out every time, but it's good practice to write it out to make sure you're not making substitution errors. So plug everything in now. 6 squared, 9 squared plus 4 squared minus 2 times 9 times 4 cosine A. Right, again, looking ahead, we're trying to solve for cosine A. So we're going to have to evaluate 9 squared plus 4 squared, subtract it from the other side, and then divide by all this in front of cosine. Just looking ahead at what we're going to have to do to solve. So 6 squared, 36, 9 squared, 81, 4 squared, 16. Negative 2 times 4 would be 8, and times 9 would be 72 cosine A. So 81 and 16 together is going to make 97. So we'll subtract that from both sides, move it over. Now I have negative 61 equals negative 72 cosine A. I can divide now by the negative 72 in front of cosine. So I know now that cosine for angle A is going to be 61 over 72. So angle A, find it on your calculator. Second cosine will give you the inverse, 61 over 72. Right, so you can round up to the nearest degree when you do these on your calculator. For this one, we'll get about 32 degrees. Right, so now I have to do the same thing, rearrange, just like we did in the last one, rearrange the formula, get a new angle involved. So whether that's B or C, doesn't matter, as long as you're solving for one of the missing angles. For the third angle, again, we won't have to put it back into the formula. We'll just use a triangle angle sum. So if we rearrange, we want to solve for angle C. I need to start with side C on the left-hand side. So C squared equals A squared plus B squared minus 2AB cosine C. Again, make sure that side length on the left-hand side matches the angle on the right-hand side. Everything else here we already have from the problem. C is 4 squared is A 6 squared plus B 9 squared minus 2 times 6 times 9 cosine C. Right now we're just simplifying everything. So we have 16, 36, 81. 2 times 6 is 12 times 9 will make 108. We're going to keep reducing 36 and 81 be 117. Right, we're going to subtract that again from both sides, trying to isolate that cosine so we can find the angle. So that'll be a negative 101 equals negative 108 cosine C divided by 108. We know cosine C is going to be now 101 over 108. So we'll use the inverse cosine to find the measure of the angle. And again, we can round to the nearest degree. This one you'll get about 21. Right, and then the last angle, we're not going to put into the formula. We'll just use the triangle angle sum. So 32 and 21 together will make 53, and then another 127 will make 180. Right, again, I can go back and check. Largest side is B, largest angle is B, smallest side is C, smallest angle is C, and A is both in the middle. So it agrees at least there, so it kept me from making at least a very big mistake on that end. So last thing we're going to do is go through an example of a word problem, and then you're going to have a chance to do some practice problems on your own. So the word problems are actually a little bit quicker and a little bit easier just because we're not always solving the entire triangle, we're just finding one piece. So here we have two airplanes leaving airport at the same time on different runways. One flies 66 degrees west to north at 325 miles an hour. The other flies 26 degrees west to south at 300 miles per hour. I want to know how far apart they will be after 2 hours. All right, so again, we're going to try and draw this as a picture. So here's my airport. All right, see a lot of directions happening in the problem, so we'll go ahead and make sure we're oriented for the directions. So one airplane is flying 66 degrees west of north. So if it's flying along this line, right, this angle right here would be 66 degrees. Going straight up, that would be due north. Now to the left would be west. That's 66 degrees to the west of north. Same idea for the second plane. It's headed 26 degrees west of south. We want to know how far apart they're going to be after 2 hours. So that's going to be this distance right here between the two planes is what we're solving for. Right, so I know if this plane is flying 325 miles per hour for 2 hours, then it's traveled a total distance of 650 miles. Same thing with the other plane. If it's traveling 300 miles an hour for 2 hours, it's traveled a total of 600 miles. Now I have two sides. As long as I have one angle or the third side, I can solve this using law of cosines. Right, so obviously we don't know the side because that's what it's asking us for, but we can find this angle right here. All three of these angles would add up to make a straight line. So to find this angle, I can take 180, which would be a straight line, subtract 66 and 26 from 180 to get that missing angle, 88 degrees. Again, now we see we have a side angle side oblique triangle. So we can set up this formula, making sure that we involve the angle we know, and then that will help us solve for the side we're looking for. So we'll just go ahead and call it x squared equals, and we'll plug straight into the formula. The other two sides, 650 squared plus 600 squared minus 2, 650, 600 cosine 88. If you're very good with plugging into your calculator, you could actually plug all this in one line, but we'll reduce a little bit just to make sure we don't make any mistakes. If you plug the first two in, 650 squared plus 600 squared, you get 782,500. And plugging in 2 times 650 times 600, we get 780,000. Cosine 88. Right now, I put this into the calculator all in one line, just like it's written right here. I'll evaluate that part for you. You'll get 755,278.4, and then we can take the square root, find our distance, which is about 869 miles. Even though the numbers are bigger, the problem itself is a little bit easier. We don't have to solve for every missing piece. We're only looking in a word problem for one missing piece. So for this problem, all we're looking for is one side, so I have to use the formula one time. So again, next year we're working on some practice problems in class. If you want to look for some different videos to help you out, on YouTube, you can look for law of cosines or oblique triangle trig.